On number 4, we are to convert from DMS to decimal form. This is actually pretty straightforward. You're going to keep the 48 degrees as your whole number part, and then this will be plus 30 minutes over 60 because there are 60 minutes in 1 degree. Let's go ahead and put the degree symbol on our 48 there. And then we're going to add to that 36, but since this is to convert it all the way down to degrees, there are 3,600 seconds in a degree because there's 60 seconds in a minute and 60 minutes in a degree. So then we can just convert these to decimals, and we get 48 plus 0.5 plus 0.01. Okay, my board and I are not getting along here for a second. Alright, and then we just add those together. So you get 48.51 degrees. And that is the decimal equivalent of the DMS angle we were given. On number 8, we're converting from decimal to DMS form, so we're going in the other direction. And so we know that we're going to have 99 degrees in our final answer, so let's go ahead and set that aside. We don't have to worry about it anymore. And then we're going to take the 0.37 part, and basically that's like a percent, so 37% of 60, so we're just going to multiply that by 60, and 0.37 times 60 is 22.2. So that step gives us that there are 22 minutes, and then we have the 0.2 to contend with, so we bring the 0.2 down and multiply that by, and that was 60 minutes that we were multiplying by. And now we're doing 0.2 times 60 seconds, and 0.2 times 60 is 12, so that tells us that we have 12 seconds. And that's our final answer. 99 degrees, 22 minutes, 12 seconds. On number 14, we are to convert from DMS to radians. So this is where we use our conversion factor. So we're going to multiply 11.83. We'll go ahead and put that over 1 because our conversion factor is a ratio. And since this is degrees, and this is the easy way to remember the conversion factor, it's always either pi over 180 or 180 over pi. And we know we need the 180 degrees on the bottom so that the degrees will cancel and leave us in radians. And then when you have decimals and stuff involved, you can go ahead and just type that in your calculator because we're going to get a pretty ugly decimal here. 0.206472. And if you leave the units off, it's understood to be radians, but just to get you used to the idea of thinking in radians, you should probably write the word radians, or at least RAD as an abbreviation for units on your answer. On number 22, we are to convert from radians to degrees, so we're going to take our 13 pi 20ths, if I can write, and multiply that by our conversion factor, which, again, we don't have degrees here, we have radians, and there's a pi on the top, there's a pi going to be on the bottom because we want our answer to come out in degrees. And then the pi's cancel, and then we can reduce this down to 9, and then 9 times 13 is 117 degrees, and that's the answer to this one. On number 24, we are to convert from radians to degrees, and it will be unusual for you to see an angle named with something as simple as 1.3, but that is, without the units, understood to be radians. So we're going to multiply that by, and remember we want to think of radians relating to the pi, so we put that on the bottom, and we want degrees to be our units, so that should be on top. And then again, when you have decimals involved, this is a calculator problem, so you just type it in, and you get 74.4845 degrees. One last example, number 28. In this set of problems, you are given either R or S or theta, and then, or I'm sorry, you are asked to find one of those, and then you are given any two of the three, and then asked to find the third. And this relates to the arc length formula, S equals R theta, and remember that's all you need when your angle is given in radians. So when S is 2.5, we're just going to replace that, and we're solving for R, so we'll leave that there, and then our theta is pi thirds. And I would like for you to do this problem without a calculator and without using decimals, even though it's got a decimal in it, because 2/5 is easily written as 5/2. So we can rewrite this problem as 5/2 equals pi thirds R. So then to get R by itself, we're going to multiply the 5/2 by the reciprocal of pi over 3, which would be 3 over pi. And then there's nothing that cancels here, so we multiply straight across, and we get 15 over 2 pi. And this is our radius, so it will be in centimeters. And that's the answer to that one, and the end of our example video for 4-1.